So hello, everybody. Welcome to this webinar today. We are happy that you're joining in such a large number. My name is Bruno Wittmer, and today with me is Michele Eliosi. We are both from the scientific team of PVsystCLI, and we will be presenting you a quick introduction into the new version of PVsystCLI, version 8, today. The webinar today will be divided in 3 parts. Michele will start by saying a few words on the features and novelties in PVsystCLI 8. After that, myself, I will give a quick overview of PVsystCLI, the PVsystCLI command line interface. And finally, we'll have a third part where we will be answering questions that will come up in the chat. So together, in parallel with this webinar, there's a chat where you can ask your questions. There's a possibility to upvote questions. If you see that the question has already been asked, just upvote them so that we keep the number of questions in a reasonable size. And we have a technical team in the background that will be moderating and sorting these questions, answering already some of them, which are quick to be answered. And then in the third part of the webinar, we'll be taking up the questions by priority and try to answer as well as we can. So having said this, with no further ado, I will pass the floor to Michele for his part of the webinar.
Thanks, Bruno. So in this first 20 minutes, I will discuss the new features in version 8. So just a few generalities first. So version 8 was released on November 7th, just a couple of weeks ago. And we already published 3 patches, so we're at 8.0.3, and this was just released yesterday. And so make sure to update if you're already using PVsystCLI version 8. And so PVsystCLI 8 comes with many large improvements, and we also had to change a little bit the logic behind how things work in PVsystCLI, so I'm glad to present this today. The installer of PVsystCLI 8 also comes with PVsystCLI, which stands for Command Line Interface, and Bruno will tell us all about it. And both can be evaluated for 30 days, so you can download it now and just start using it directly. And you can go to our webpage, and it's going to be very easy to find where to download this. So let me first give an overview of the situation we were at PVsystCLI 7. And so PVsystCLI 7, especially 7.4.8, was very robust and allowed to do many things. And generally speaking, it's a version that works very well, but it had one main limitation that basically we were limited to only one orientation type per variant. And so this could be problematic in 2 ways. If you imagine a realistic system, it can have a lot of complexity. And some systems may have multiple types of orientations, for example, trackers and fixed tilt in the same place, or multiple tracker types, and so on. And so the first drawback was that we could not model this type of systems. And the second drawback is that even though you could model other types of systems, sometimes you needed to do an approximation in which you averaged, for example, multiple azimuths or multiple geometries into one average orientation. And this had an impact on the loss modeling because we're working only on that average orientation. And so for that reason, we may have had some inaccuracies due to this averaging. And so this has motivated us to develop version 8. And so the solution was rather simple, is simply to allow for any number of orientation to be described in a same variant. And so this solves both problems. We can now model both trackers and fixed tilt in the same orientation, or different types of fixed tilts and so on. And we can also have a more accurate modeling because of this, because each orientation is represented properly in the variant, and so we can use that for the loss modeling. And so let's now look at this in practice. I'm gonna bring PVsystCLI out, and let's see with a project we prepared here. And I'm gonna open this first variant. All right, so first, let's enter the orientations because that's where the main improvement is. So you can see that the interface compared with version 7 has changed a little bit in that we now have a list of orientations. With all the space that is here below, you can see that you could add many more, and there's actually no limitation to how many there are. So here we have two fixed tilt orientation, which we can see at a glance. And to change the parameters, you can just unfold and enter any parameters here. Here, these are grayed out because I have a 3D scene that's linked to this orientation. And so the nice thing about this is that I can very simply add an orientation. And here, since I had fixed tilt, let's add trackers orientation, for example. And here I have no problem. I can change the different parameters. And let's add backtracking, for example, and press OK. And now I would like to show you a simulation. So just to complete my system, I should define which modules are on this tracker orientation. So I'm going to go to system. So here for PVsystCLI 7 users, you will notice that the subarray list is on the left. Let me just copy one of these subarrays, which means I will just copy the definitions of the modules and the inverters. So I have my third subarray, and I can now select the trackers orientation. And so with this, I'm ready to go. I have a module, an inverter, and strings, which are defined for every orientation. And I can just run the simulation. And so what I did here, you can do with any number of orientations. And every time you have a new orientation, you can basically have new parameters. So you could imagine many differences, for example, electrical differences or differences in the 3D scene and so on. So now if you check the report, all those differences will be described. Let's go to page number 3. And so, oh, sorry, let me zoom in. Here in general parameters, you will have the different orientations being displayed with their respective parameters. If you have bifacial models, which you may have one by orientation, those will show up also here at the bottom. And then if you look at the shadings page, you see that you have an ISO shading diagram for each orientation. Finally, the results are aggregated for the whole system. So this doesn't change. And so we will properly sum everything up to give you the total loss diagram. And so this is just a simple example of how we can add multiple types of orientations. And this is a thing we could not do in version 7. So now let me just go through a few more examples to show you the versatility of this. So I don't need to save this. I'm going to go to this flat roof, which has 6 fixed tilt orientations. And I'm going to show you the 3D scene. So you have one building and 6 arrays, and those are all bifacial arrays. And so one of the limitations of PVsystCLI 7 was not being able to have multiple types of orientations and a bifacial model associated to it. We were in fact limited to only one bifacial model. Whereas here, we can look at the system page. And you will see that each of orientation is assigned to a subarray. And each time we have a different bifacial model. So this is the orientation, has a specific azimuth here. And if I go to number 2, I will have pretty much the same orientation number 2, a different model, and a different azimuth. And so like this, we can gradually add more bifacial models to the project. I will show you a second example, the wider pitch here. And if you want to do backtracking, you would prefer that this move independently. So for this reason, even though they're the same type of trackers, we define two different orientations. If we then go to the backtracking management, you will see that you can have different parameters for each of the orientations. And so another possibility that was added was to see that, okay, given certain parameters that are, this is for one of the two orientations, you will see which trackers have a lower pitch than that and have some increased risk of being shaded. So of course, with the topography, there is going to be some shading due to the topography, but the one due to the pitch will be highlighted in red. And now I can swap to the other one. And here, yeah, here everything has the same pitch property. All right, and so this is another possibility that was just introduced with version 8. Now, of course, there's other developments with version 8, and I will go through 3 directions, actually. In the 2 next slides, I will describe first how we try to make the simulation more accurate. Second, how we just made general quality of life improvements to the interface. And third direction is something I will just mention here, is that we'll keep updating our component databases, our weather databases, and so on. So PVsyst ships with Metronome 8.2 now. And so you can always find more optimizers, inverters, modules, and so on in our database. So for all improvements, if you're interested in the details, you can look at our release notes there in this webpage here. And you will be able to experience also the new interface for our help. So let me first describe how we make the simulation more accurate. So the main improvement here is a new so-called sub-hourly clipping correction model. The idea is that with high-frequency irradiance fluctuations, those can lead to some clipping losses that are not seen by an traditional hourly simulation. And so this means that we're basically missing a few losses, especially for small arrays. And so the solution to this was to consider more high-frequency time series. So we have the possibility to upload to PVsyst a sub-hourly time series. And with the new functionality, which just necessitates checking a box that states clipping correction, we will store some information on the sub-hourly scale that we will then use in the hourly simulation. And this information will then allow to model the missing clipping losses that we would not have seen in version 7. And so the results will be simply nothing will change in your procedure once you design your project. But once you look at the losses, especially the clipping losses, you will find that we have added a contribution from this model. And so this is really us trying to moving forward in making the simulation more accurate. And this opens up a lot of possibilities. So we're really glad to implement this. Now I will move to the more interface and quality of life improvements. So 2 examples here for this slide are the topography and satellite image import directly from the 3D scene, which I will show in a minute. And the second is the newly designed help, which is much more easy to read and to search. So we're looking forward to having your feedback on that. And so I would also like to see this within PVsyst. So let's, maybe I will open another project, the residential one. And so here you have just simply a house. But what counts here is that we want to import some topography for this location. And I will go to import and download the satellite ground image and topography. And I will try to choose a place where there is a hill so I can zoom in. If I want to import the topography data on top of this image, I just need to check here on import topography data. And so this will take just a couple of seconds. And there you go. So now you have a topographical layer that was imported with quite some details, and then you can start designing your scene as you would do. So that's the first improvement. And then just to show you the help, we have, I just pressed F1 to open the help. So we have this newly designed help with the search bar that's a bit more usable than before, and a dark mode for those who like it. All right, so I'm at the end of my part. And well, just to summarize, so we're at version 8.0.3, so feel free to update. And basically the first few patches were mostly crash fixes. So now this version is much more stable, so be sure to update. And so PVsys 7, if you have a PVsys 7 license, this is carried over to version 8. So you don't need to do anything about that. You can just download PVsys 8 and keep working. And so within PVsys 8, the main changes are the multiple orientations, which opens up a field of possibilities, the sub-hourly clipping correction, which makes the simulation more accurate, new tools in the 3D, and PVsystCLI, which Bruno will describe now.
Thank you very much, Michele, for this nice description. So I will take over now and say a few words on PVsystCLI, or the PVsyst command line interface, which is new, was released with PVsyst version 8 and is now available for using. So what is the idea of this CLI? Basically, if we look at that desktop version of PVsyst, you can already do a lot of things with them. You can improve your system, make simulations, change your parameters, rerun the simulation and gradually optimize your system, or you can analyze the sensitivity to certain parameters. You can also, with updated weather data, rerun your simulations. But of course, this is not an automatic workflow. And the idea is now that this barrier of the user interface to integrate PVsyst into an automatic workflow will be covered by PVsystCLI, the command line interface. So the command line interface will allow you to perform certain operations of PVsyst without using the graphical interface. You just type a command line on a terminal, and this will trigger the execution of PVsyst in the background. And this, of course, will open the possibility to integrate PVsyst in an automatic workflow. So how does this look like in practice? It is simple. If you have a terminal window, you just type commands in there, and I will run you through an example right now. Just to say at the beginning, we started by putting two main features into this command line interface. You have some commands to manage your license, but the commands which are highlighted here are the ones which are doing real work. The first one will convert weather data that has been measured from an external input into the PVsyst format to allow to run a PVsyst simulation with it. So if you get updated weather data, it's not necessary anymore to manually open PVsyst, import that data to create the so-called MET files, the MET files with the MET extension. This can now be done automatically via the command line. And the second functionality that was built into PVsystCLI right now is to run a simulation. So you can run the simulation without using the graphical interface. You can do this with a command line, and this will be the first example that I will show to you. So as Michele has already said, the PVsystCLI is installed together with PVsyst 8 when you install it on your PC alongside with the graphical user interface. and you can try it out. There's a trial period where you can just use it, but also the number of calls that you can do to the command line is limited to 250. So once you have used up this quota of 250 calls, you will need a license for PVsystCLI, which is a separate license, to continue using the features of the command line interface. So I'll be going back to PVsyst and show you. We'll just close the windows that Michele opened and get you back to the starting screen. So if you want to run the command line interface, basically you need some pre-existing PVsyst projects and a PVsyst workspace on which you do these operations via the command line. And I will do this example here right now with the workspace that we were using for these examples. And if you, on the starting window of PVsyst, you have this link here to the Windows Explorer. If you click on that, the Windows Explorer will open and show you the workspace of PVsyst with all its projects. So the projects are in this project folder. We will use that in a second. And the weather files are here in this Meteo folder that you can use. There are many other folders. I will not go through the details right now, just to say that I will be working on this folder on our disk where our workspace is. So if you open the terminal on this window, I have it here. This is where my corresponds to the workspace that we are seeing right here. And the first command is very simple. You just type PVsystCLI and hit enter, and this will be installed on your computer. You can run it. And if you just type PVsystCLI, you will, of course, not do any action. You will just get the list of available commands that are possible with PVsystCLI, as you've seen on the slide I've shown before. And the two commands I will use for our example is this convert meteo and the run simulation. And here you see the other commands, which basically do the license management and show you the version, the current version that is installed. You also see that there is a links down here to the help of PVsystCLI. There's a specific help environment for explaining this command line interface. And in principle, you can open this in a browser and get to a help page which explains it. There is the help is also installed locally, so you don't forcibly need an internet connection to see this help. You also have it installed locally together with PVsyst. So I want to run the simulation, and in this first example, we'll just execute a simple simulation and create the PDF report, but without using the graphical user interface of PVsyst. So I'll type PVsystCLI. The command is run simulation, as it's shown here. And it takes several parameters to tell PVsyst which simulation should be executed in the end. And to see this, you can just type help and the command you want to run. Yeah, run simulation. I missed the V. So here you get an exhaustive list of all the parameters you can pass to this command. This includes input data, the weather file, the site file. You can change that. You can, what's important for us is to specify the workspace, the variant, and the project that we want to simulate. And as an output, we want to create a PDF report. So as you see here on the left side, there are always two versions of these parameters. There's a long version where you can explicitly read it. It's easier for a human to read this. And on the right side, you see the short version of these options, which are easier for the human to type into the command line. Yeah, so it's your option if you want to be able to read it or to type it quickly. So let's do this. PVsystCLI, run simulation. The first parameter is the workspace I'll be operating on. The shortcut is W. And I will just put a dot to say that I'm using the current workspace, the current folder where I am in, which is the PVsyst workspace. The next parameter will be the project. I will be using the project that Michele has used for his example. Let me quickly copy it from our project folder. So it's just this project here. I will copy the name to my command line.
I will use my my possibility to ask directly a question, but don't you need the dash before the options?
Yes, you are quite right.
Yeah, for the W.
I would have gotten an error message if I would have missed that. Thank you, Michele, for this correction. Next, I'll need to specify the variant. So this is the shortcut is -v. I will take the first variant, VC0, with a naming convention PVsys. And finally, I want to create a report. So the PDF report, the parameter is here -rpf. So I will do -rpf and just say PVsysT report.pdf. And that it is. This is a very simple execution. So it's the minimal requirements that you have to do for executing a simulation is to specify the workspace, the project name, and the variant. And here, optionally, I'm generating the PDF output. So I hit enter. PVsystCLI will start. It's verifying the license. It's loading the variant.
Oh, right. I simulated. So
you simulated it before.
Apparently. So okay. You should add the option at
minus
the end.
override. Yeah. Minus override.
Default.
Default.
Yeah.
CSV. So you see the execution of the simulation. There is some feedback as you're executing it, and you get all the warnings and error messages that you would also see in PVsystCLI. So in here, you see that there's a warning about a slightly oversized inverter power. It's the same warning you would see if you would open this variant in PVsystCLI. And finally, the report is being generated in the end, and we'll have a look at that right now. So the simulation is hopefully finished.
Yeah, I think it might take some time if it's the first time activating the PDF generation.
Okay, let's give him some time. We'll say a few words. Let's give him the time to install the PDF converter, which was not done on this PC. I'm sorry for that. But basically, you see here the most elementary way to execute a PVsystCLI command and run a simulation without the need of using the graphical interface. And this is basically the idea. Of course, in reality, you will not be typing manually commands on the command line to execute PVsystCLI. The true power of this feature is that you can integrate this now in different scripts that automatize your workflow. You can PVsystCLI as PVsystCLI is always installed on Windows, so you need some Windows environment to execute scripts. But you can use Windows batch scripts, you can use Python scripts, you can use R scripts, you can use many type of scripts just to invoke this PVsystCLI command. And we see here now that the PDF generation finally ended. And you see here now in the folder where I was working, there is a PDF report, and I can just open it and see the PVsystCLI report for the variant VC0 of the project that I had selected. Good. So as I was saying, the idea of the command line is not to run them, type in the commands manually each time you want to do something, but to integrate them into scripts. And as possible use case, we have thought of the possibility of running a simulation on updated weather data. So the scenario here would be that you have an existing PV system. You have your PVsyst model that describes your PV system. It's operating, it's monitoring data, it's measuring the weather data and the PV generation. And basically, as the weather data is coming in, you want to update the simulation results, either to compare them or to see if something is, if the installation is operating as expected. So PVsystCLI can do this in 2 steps. So the first step would be to import the new weather data and convert it to the PVsyst format. And the second step then is to run the simulation with this updated weather file. And this is a slightly more complex example than what I've shown you before. And to exemplify this, PVsyst ships with several examples where we have scripts that you can look into that give you different use cases, and this is one of them. And I will quickly show you how you can do that in PVsyst so that you can start exploring and changing these examples by yourself. So I'm going back to PVsyst. In our workspace, if I open it with this Manage button, I see the folders again of this workspace, and there's a workspace called PVsystCLI demo. And this is where we have put some examples for you that run out of the box in principle. Every data that you need to run these examples will be there. But right now, if in your default installation, these folders will be empty. And to populate them, you have to click on this Reload Templates button here. If you do that, PVsyst will just simply populate these folders, the templates folders and the demo folders with its templates. So in the templates, there are weather file templates and load profiles. But what's interesting for us here now is this PVsystCLI demo. And you see now that there are many files in here for different examples. There are 3 examples for Windows batch files that we can run. And this is the example I will show you, this next day forecast example. But you also have more complex Python and R examples. So let's go back to our Windows Explorer. And you see now that there is a new folder called CLI in here with all these examples that are in there. And we will look into the scripts of the Windows shell with these 3 examples. The first one, the simple simulation, is basically what we did right now by hand. We could do it in a single go. And I will show you this next day forecast script. I will open it. Here you see it. If you're not acquainted to Windows scripting, let me just say that the command sets environment variables. In this case, these are the paths and file names that we'll use for this command. And then we check if these folders for the results exist. And the true PVsystCLI invocation comes here at the end. You see that there are 2 commands which invoke the command line interface. The first one does a weather file conversion, and it needs a site for which the weather file is defined. So this needs to be done beforehand in PVsyst, and it needs the conversion format, which has a file extension MEF in PVsyst. This is a file when you import custom weather data in PVsyst that describes where PVsyst will find in the CSV files the columns for the different types of variables. So you need to prepare this beforehand, this format file in PVsys for the format of your weather data that you are monitoring. Once you have that, with this simple command, you will generate a MET file, so the weather data file, internal weather data file format of PVsys. And then in a second call, this script will run the simulation with a new weather file that was created in the previous step. And this, of course, now is a long script that can be executed automatically. So I just need to double click on this, and you will see that all these steps are now being executed automatically. And this is an example of an automated workflow. So if you have prepared, if you have an existing PVsys project of your installation, which contains a site file, and you have prepared this format file for your weather format, you can continuously do this integration of new weather data into the results. You see the simulation has finished. You see there is much less output than before. And this is because you can control the verbosity of the output on the command line. So you can have a lot of feedbacks with many informations and warning steps, or you can be very quiet, execute very quietly. And you can also redirect all these messages that come from the command line into log files. And this is what has happened here. This is why the screen is quite empty. All the results were routed into log files, which I will show you. So in this example files, we have here the results now. This was a result of the file we were just executing. You see that we have the logs, the simulation logs, and the weather input logs for the two command line interface commands that we executed. We can quickly open this to have a look at it. So it's basically what you've seen before on the terminal when I executed the command manually. This is now written into a file for further reference. So this is important. If you fully automatize your workflow, you won't be looking at the terminal while these things are executing. You need to find all this information later in a log file. The second number of results is here now, the CSV file. These are the hourly simulation results of PVsystCLI, of the simulation we just executed. It's a regular output file, as you can create it already with PVsystCLI. If you go into advanced simulation output file, you can create this kind of CSV files with the output. And for the command line interface, you can configure also directly what you would like to see as output in these files. I will not go into this detail, but in the help, in the explanation of the parameters that you can supply to the run simulation command, you will find all the parameters that specify how you control the output into this file. We didn't generate a PDF report for this example. We could have done so, but in this example, the only other thing we've generated is this weather file, the MET file that was generated with the first command line interface. So you see that it's possible to make a slightly more complex scenario like this one in a fully automated way. So what we did was basically we had 3 days of simulation, and we added a 4th day with the incoming data and generated the simulation results for the complete weather data set. So this is one use case that could be interesting for using the command line interface. Another one is slightly more complex. I will show it you on the next slide. It's basically in PVsystCLI, we have right now hourly simulation steps. The step to going to sub-hourly simulation steps will come in the next major PVsystCLI release, 8.1. But up to now, there is a possibility to do a sort of pseudo sub-hourly simulation by splitting your input weather data into slices of minutes, for example, which are then yearly files just for 1 minute in the hour, run 60 simulations on these slices, and then reassemble the results into a minute output file. You see the result of such an exercise here on the right side. And if you do that manually, it's quite time consuming and error prone. And PVsystCLI would be the possibility to automatize and to simplify greatly this exercise. And in fact, with the examples that come with PVsystCLI, this scenario is also there in a slightly more sophisticated script which uses Python. Yeah, so in these Python scripts, we have 3 examples. This next day forecast is the same that we did with the Windows batch, but with Python. And here you see a more complex script now that does the slicing into 60 individual CSV files, imports all the 60 files into PVsystCLI, converts them to MET files, and then runs a simulation of one variant on all these 60 files, and in the end reassembles the CSV output into one single minute file output. So if this kind of scenario would be important for you, you can just take the examples that you find in here, if you use Python, for example, and adapt it to your specific project, to your specific files, and run it. You can, this example also runs out of the box. I will not do it here because indeed these are many simulations. So these are 60 importing steps of weather data and 60 simulations that run. This would take quite some time that we don't have here. One strength of PVsystCLI now is that you are able to parallelize these 60 simulations. So in this particular Python scripts, this is already done. So if you try this out by yourself, you will see that the 60 simulations will run in parallel, will make use of all the cores of your PC, which speeds up things significantly. You could do before in PVsys these kind of sequential or many simulations in one go with a batch mode, but also the batch mode runs serially, not in parallel. And PVsystCLI now opens the door of using really the full potential of the cores that you have on your PC to run in parallel. If you look into this example and try it out, anyhow, be careful because this will be 120 calls to PVsystCLI. So you have 250 trial calls. You will use up 120 of them in one go if you just run this example. So think carefully before you just start doing this. If you want to use your trial calls for more things else, you will have to buy a PVsystCLI license to go on using PVsystCLI on your environment. Good, and with this, I basically gave you a quick overview of what's possible right now with PVsystCLI. We are going to improve the features of PVsystCLI. So we have these two commands right now for importing weather data and running simulations. And the next step that's on our agenda will be to integrate PVsystCLI now with the PVsyst batch mode. And this is interesting. First, it might sound redundant because you say the batch mode is to run multiple simulations and you can do this PVsystCLI anyhow. But what you can do with the PVsyst batch mode that is not there in the command line interface right now is to change simulation parameters. So this will be the big plus. If we integrate the batch mode with the command line interface, you'll be able to automatically change many simulation parameters via the command line to run simulations. And this opens the door for several possible scenarios. One would be an automatic optimization of certain system parameters. For example, if you have a system with storage and you ask yourself, what is the optimal battery capacity and PV capacity for the system? You could execute a series of simulations where you vary the battery capacity and the PV capacity, and then, for example, make a financial evaluation to optimize the net present value or the return of investment or LCOE or any other kind of variable you would like to calculate. And you can do this already with a batch mode, but there again, you have to interact manually with PVsys. And if the command line interface would be able to operate the batch mode, you can do this now, could do this in an automatic way and get these sort of maps where you map the PV capacity against the battery capacity and calculate, for example, NPV, net present value, as in this example, and find the optimal point for your PV system size and for your battery size. So this is one possibility, optimize system parameters. There are many other system parameters in PVsyst that you could try to optimize in this way. And the second scenario for using the batch mode with CLI would be to make a fully automated sensitivity analysis. So how does the simulation result react to a change in some parameter? So the idea here, for example, would be that you make a bifacial simulation, but you have some uncertainty on your ground albedo. It's not a precise value, but within a certain range. And you want to understand how this translates, how this propagates to the PVsyst results, to the output. And then with PVsystCLI, you could just vary the ground albedo parameter for your simulation, run automatically these simulations, and get the yield uncertainty, so the mapping of a ground albedo uncertainty to a certain yield uncertainty. So this is the second scenario where this batch mode integration and CLI would come in handy and would open many possibilities that you could think of understanding the impact of changing simulation parameters on the simulation results. And with this, I'm done with my overview of PVsystCLI. I thank you for your attention. I thank again also Michele once more for his part he did.
Thank you.
And we will now take over for the question part. Michele.
So we will. So I think our moderation team already answered some questions in a written way, but we still have some questions left for us to answer. And I see that there's a lot of questions with that start with when. And sorry, I think we will maybe group all those questions at the end and answer all of them regarding the roadmap. But maybe let's take a more direct one. So Bruno, can you answer whether there is some sub-hourly export in PVsystCLI?
Now, if by export you mean simulation results, this will come once the simulation itself runs in sub-hourly steps. There is no way to take the hourly results and convert them or somehow deduce some sub-hourly behavior from that. So right now with PVsystCLI 8, you export hourly data as before. You can, with this example that I showed with this pseudo sub-hourly simulation, you can basically make a workaround and get something which comes quite close to sub-hourly simulations. There is the thermal inertia of the PV modules which is not in there, and if you have systems with self-consumption and storage, you don't see the battery state of charge evolving. So these are scenarios that you can't do, but any other scenario you can do in this way, and you will get a result which comes very close to sub-hourly simulations. But the true answer to this is once we have 8.1, which is the one where we plan to have the sub-hourly simulation steps, then you will be able to also export directly from the simulation the sub-hourly results.
Great, thank you for the answer. Then I have a question that was forwarded to us. Bruno, maybe you can read this one.
Yes, the question is when will the backtracking algorithm be updated in order to properly calculate shading losses when there's topography in the 3D scenes? So this is a question that comes up often. It's quite ambiguous. It has a complex answer. And Michele, maybe you can say a few words on that.
So it's quite a meaty question because there are multiple aspects to that. So first of all, in terms of just modeling shadings, PVsystCLI is doing basically what can be done. I mean, we are already modeling the shadings in the 3D scene with trackers and with backtracking including, that's correct. However, I think where the question wants to go is, do the trackers move as they move in a specific real life field? And do they backtrack and do they adapt to the topography? And this in PVsystCLI is still to be improved. So right now, the trackers follow the, let's say, standard backtracking procedure in which it is assumed that they're on flat ground and they all move in the same way within an orientation, of course. So you could have trackers moving differently, but they have to be in different orientations. But we plan to improve this in the future. So, and I think I will be answering many of the questions that I see on the left with this. Basically, we plan, of course, two improvements. One would be to have a topography specific algorithm that we could apply, and so that they would move independently. And the other answer to that would be to import tracker angles. And this is also something that you would like to do. And in this way, you could model your own algorithm, because there's a variety of algorithms out there. Bruno, maybe you want to add something?
Yes, so this is indeed on our roadmap, so we can improve the tracking algorithms that are built into PVsystCLI for backtracking, for example, on a slope, on a constant slope, and then do some approximations there. But it's true, as Michele says, the tracker manufacturers often have their proprietary algorithms, and we don't know in reality how a tracker will move on the terrain, what has been implemented exactly. Sometimes these are even calculated online, the positions there. So it's very hard to translate this or to to implement this right like that into PVsys, and the solution to that will be to import externally the tracker position so that a tracking algorithm would somehow run outside of PVsys, and we will import the positions and adapt the 3D drawing according to this external input. And this is on our roadmap, I would say not for the coming year, but for the year after.
Let's take a CLI question. So let's take maybe this one. So one person asked whether there is an API available. And second question, is it possible to couple the simulations using PVsystCLI and other models?
Yeah, so I guess the question here is whether you can communicate with the PVsyst simulation as it executes. Yeah, this would probably be the idea of an API, that while you're executing a simulation step, you get some inputs externally from other processes which are running. This is indeed something we are thinking of, but there is no true timeline for the implementation of this feature. But of course, this would also be important, or could be even nicer in the context of a tracking algorithm we've just been talking about, that adapts or calculates the tracker positions on the fly, and could inject that into the PVsys simulation as the simulation executes. Could also be an interesting feature if you look at more complex ways of dispatching energy, if you have storage and self-consumption. But with PVsystCLI right now, this is not possible. You just execute the simulation, you have access to the results in the end. But in fact, we are thinking of how this could be possible in the future. Yeah, but there's no really roadmap for that right now.
Yeah, maybe I would like to add that, I mean, right now you can, as Bruno said, launch a full simulation and then see the results. So insofar, that's what you want to do. So if you want to just have a specific model that generates some input for PVsys and then run the simulation and then use the output of PVsys for your other process, this you can do. But playing with the simulation while it's running, that's something for the future. All right, let's see, there's actually a lot of questions, and so it's a bit complicated to choose one. Maybe Bruno, if you see one.
Yes, there is one question. Can we do a glare simulation by using the software? So this is on our roadmap for the next major version 8.1. And if everything goes well, this will be available by the end of next year.
All right, another question on PVsys, but maybe Bruno, you will be able to answer. I saw a couple of questions about back contact technology modules and whether we have a roadmap for that.
Yes, so the back contact IBC technology is in fact growing, and we are following this evolution and tried, first of all, to make sure that the modeling of the PV generation itself of these new technologies works within PVsys, and this is our main priority. They also seem to have some particular behavior for partially shaded situations, and we are looking into this. This would be important in the context of the module layout tool that we have in PVsys, which models the electrical shadings. And for the back contact technology, there is no specific roadmap, but it's included in all these updates that we do and the improvements of the module layout tool that is within PVsys. So we are following this, and then certainly if the back contact cells will become a dominant technology or a very significant technology, we will give priority on making sure that they are well modeled within PVsys.
Yes, so there, I would say that there's many things that we want to do. So I think most of the questions that are in this list are in our roadmap somewhere. Then it's always a question of how to prioritize things. So yeah, I see. So, did you see one?
Yes, there's an interesting question. What temporal resolution is needed for PVsys to run sub-hourly loss correction? So I guess these are the clipping loss corrections.
Yeah.
Would 15-minute weather data be sufficient?
All right, that's a great question. I'm glad to answer that. So to use the tool in PVsys, so you can use any sub-hourly time interval. So 15 minutes can be used, 5 minutes can be used, 1 minute can be used. It goes actually up to 1 minute. Then the question is, what is the most appropriate? And there, it's also a technically complicated question because it depends on basically the scale, spatial scale of your system. If you have a central inverter, you can assume that very, very high frequency fluctuations would not play a big role, because with a central inverter, you're averaging over many different strings. And then the fluctuations of the DC array would be rather slow or kind of averaged out. And so then for that case, maybe 10, 15 minutes, that's fine. If you have string inverters with short strings, then those high frequency fluctuations become important because you're looking at a small size. And if you're using a single pyranometer data, for example, there you should start looking at lower timescales. So that's the whole complexity of the problem. It's like finding the right scale for the right problem. And finally, I can add that the best thing to do is if you have multiple irradiance measurements that represent the scale of your system, and then you can average those out before entering them in PVsystCLI. And so there, no matter the time resolution, you should be able to have a proper description of those clipping losses if you're averaging spatially already.
So there is one more question. Is there a limitation between the different orientation values in a same PV plant layout?
No, there is no limitation. That was a simple one. So you can add as many orientations as you like, and you can have different backtracking models for each of them, different bifacial models for each of them.
Next, can we use different orientations to force different backtrackings in the same layout?
Yeah.
That was one of the purposes, right?
Exactly. So we can have multiple backtracking orientations.
So there's a question for the command line interface.
So do we need to type the parameters in a specific order, or it doesn't matter, maybe?
No, it does not matter at all.
Okay.
The parameters are specified by their name, and you can put them in any order you like.
So, yeah.
Yes, so I'm just getting the message that the webinar will be stopping within 2 minutes. So maybe we can answer one last question. Michele, I'll let you pick one.
Let's try to find a good one. Yeah, maybe the mixing. Okay. Yeah, I'm going to go for the mix orientation.
When mixing multiple orientation into the same MPPT, especially for the case of central inverters, are the losses considering all orientations or just the average of these orientations into the same MPPT?
So that's a great question because it highlights one thing we still need to improve in PVsystCLI. So right now you can mix up to 2 orientations on the same MPPT. And so there we consider those 2 orientations, and it could be any 2. So it could be orientation number 3 and orientation number 5 on that MPPT. And then on another MPPT, you would have number 6 and number 2. That's, for example. So that's okay. And in the future, of course, if we see that that's something common in the project, then we could improve this feature and mix many different orientations, I would say. But right now, that's not possible.
Okay, thank you, Michele, for this last answer. I thank also all the participants, everyone who joined us today here for the interest in PVsystCLI V8. I hope it was helpful for you to see this quick overview. If you have any questions, you can contact our support lines via email or on the forum, as you know. And I hope you will will benefit from the improvements that we try to introduce with PVsystCLI 8, and just stay tuned for the further improvements that we'll be publishing on a regular basis. Thank you very much, and thank you, Michele, also.
Thank you, Bruno, and thanks to our moderator team. We'll try to keep all those remaining questions, and maybe we will answer them in an FAQ somewhere. That it would be good to not leave them unanswered, I would say. Thank you very much.
Thank you very much.